In today's lecture, we are going to learn what is common subexpression elimination in code optimization. So, I am going to take one example that, or we can say what is common subexpression means if any expression in our code is common, then instead of writing that code again and again, better we can remove it. So, we will learn with the help of an example. Suppose one example is x is equal to a plus b, y is equal to a plus b plus c, and z is equal to a plus b plus c plus d. That is the expression, or we can say that is the code. So here we are able to see that every time we are using a plus b, a plus b, a plus b, right? So this we can say this is common subexpression, right? So instead of writing it again and again, what we can do, we can eliminate it. We can eliminate it. So how we can do that? This is the example, and the solution for this, how we can write it, we can write like this: x is equal to a plus b. Now instead of writing a plus b again as we have done here, we can replace a plus b with x, because we have assigned a plus b value to x. So we can write x plus c. And in the similar way in z, now we are able to see what we are writing: z, a plus b plus c. So this entire a plus b plus c is equal to y, right? So instead of writing this whole again, what we can write? We can write y. So we are writing y plus d. So in that way, we can remove the common expression from the code. So this was the one example. Now I am taking the another example so that you can understand it better. So suppose this is the code. I am writing here like this. T1 is equal to 4 into I. T2 is equal to array of T1. T3 is equal to 4 into I. T4 is equal to array of B. T5 is equal to T2 into T4. T6 is equal to product plus 15. Product is equal to T6, and T7 is equal to I plus 1, and I is equal to T7. Suppose this is a code. So here we are also able to see that some common sub-expression is there, as we are able to see here. We have assigned 4 into I is equal to T1, and again 4 into I is equal to T3, right? And here also we are doing increment and all these things. So how we can remove it, we will see. Here now instead of this, I am making the DAG of this code. So how we can eliminate the common subexpression. So suppose first I am taking this one, T5. So I am writing multiplication sign T5, and I am writing here T5 is equal to T2 into T4, right? So in T2 what we have assigned? This one. So I am assigning like this, and I am writing T2. And T4 we have assigned this, right? So I am also assigning like this, and I am making it T4, right? So T5 is equal to T2 into T4, right? T2 into T4, right? Now what we have assigned into T2? A of T1, right? So instead of A of T1, what I am writing here? I am writing here A, right? And here we have assigned B, right? T4, B of T3. So I am writing here B. Now in T2, what we are assigning, right? In T2 what we are assigning, we are assigning first, before that, what we are assigning? 4 into I, right? So I am writing here T3, right? 4 into I, 4 into I in T3 and T1 both. T1 and T3 we have assigned 4 into I, so I am writing here 4 into I multiplication, right? So I am writing here T1 comma T3, right? So this line is over, 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 right? Now what we have left? We have left product T6 is equal to product plus 15, right? And what we have left, we have to assign its value to T6, right? So these two lines are together, so I can draw it here, and this is not correlated with it, so I am drawing here. So you can see here plus 15 and prod. prod, right? T6 is equal to, so here it is T6 is equal to prod plus 15, and we have assigned T6 value to prod, so I will write here prod also, comma prod. Now what is left? T7 is equal to I plus 1, so I will make it here I plus 1 and T7, this is plus and this is T7. T7 is equal to I plus 1, right? I plus 1 T7, and we have assigned this value to I, right? So I am writing here I. I'm writing here I. So in that way, instead of writing this much code, and I have eliminate this line here, you can see here that this one line eliminate, because both the things are same, T1 and T3. So I have eliminated here. These two lines are also eliminated, make it 1, right? And these two lines are also eliminated, make it 1. So like this we have assigned it, and we can make the common sub-expression elimination in the code. So these are the two examples, and with the help of these examples we are able to understand what are common sub-expression and how we can eliminate it in our code, in code optimization, in compiler design. So that's all about this topic. In next lecture we are going to learn machine dependent code optimization techniques. If you like it, share it, subscribe it, and comment below. Thank you.